Hi, everyone, and welcome to this session on key concepts behind AI. If you've ever wondered how machines can learn, adapt, or make decisions, you're in the right place. Artificial intelligence, or AI, is no longer just a futuristic idea. It's in our phones, our classrooms, and even our hospitals. But before we can build or work with AI systems, we need to understand what's happening behind the scenes. In this session, we're going to explore 5 essential ideas that make AI work, how AI differs from traditional programming, what machine learning is, the engine behind most AI today, how AI learns by training on data, the limitations, because AI isn't magic, and finally, a simple summary to help you remember the key points. By the end of this video, you'll have a clearer understanding of what powers AI systems and how they're changing the way we solve problems, make decisions, and interact with technology. So let's get started. Let's begin by comparing two approaches: traditional programming versus artificial intelligence. In traditional programming, we write rules step by step to tell a machine what to do. It's like giving exact instructions to a computer. If the light is red, stop. If it's Monday, send the report. Every scenario must be coded manually. This approach works well for predictable tasks. But what happens when the input changes or when there are too many possible conditions to code? That's where traditional programming struggles. Now enter AI, specifically machine learning. Instead of writing rules, we give the system data, and it finds its own rules through patterns. Here's a helpful analogy. Imagine two chefs. The traditional chef follows a strict recipe line by line. The AI chef tastes 1,000 dishes and figures out how to make the perfect one on their own. That's what AI does. We show it thousands of examples, and it learns the rules by itself. This is a major shift. We're not just programming machines, when we're training them to learn and adapt, often in ways we can't fully predict. Now, let's go deeper into machine learning, or ML, which is the most widely used technique in AI today. So, what is it exactly? Machine learning is when a computer system improves its performance by learning from data without being explicitly programmed for every single outcome. Let's use a simple example. Imagine you want to teach a computer to recognize cats and dogs. You don't write if pointy ears, then cat. Instead, you feed it thousands of labeled images of cats and dogs. Over time, the AI picks up on patterns. Cats often have smaller noses, triangular ears. Dogs might have broader snouts or floppy ears. Once trained, the system can look at a new image and say, "This looks like a cat," based on what it has learned. And the more data it sees, the better it gets, just like a human learning from experience. In fact, machine learning is already everywhere. In email spam filters, voice assistants like Siri or Alexa, product recommendations on online shopping sites, even in medical diagnostics, where it helps spot signs of disease in x rays. Machine learning is not magic, and it's data, maths, and smart algorithms coming together. So, how does an AI system actually learn from data? The process is typically divided into two main phases: training and prediction, also called inference. Let's break this down. Training phase. This is where the AI studies a large amount of data. For example, if it's learning to detect spam emails, it will be trained on thousands of emails marked as spam or not spam. During this stage, the AI finds patterns in the data, like certain words, phrases, or sender behavior that are common in spam. Prediction phase. Once trained, the AI can look at a new, unseen email and predict whether it's spam or not. This is what happens in real time. And it's where the AI puts its knowledge to the test. Think of it like preparing for an exam. Training is the study time, reading notes, practicing problems. Prediction is the actual exam, applying what you've learned to new questions. This model applies to many other use cases: translating languages in real time, diagnosing illnesses, recommending music or movies. The better the training data, the smarter the AI. But that also means AI is only as good as what it's trained on. It's easy to get excited about AI, but it's important to remember that AI systems have limitations. Let's talk about three major ones. Data dependency. AI is heavily dependent on data, both in terms of quality and quantity. If the training data is biased, missing, or not diverse enough, the AI will learn the wrong patterns. For example, an AI trained only on male voices might struggle to understand female voices. It can make mistakes. AI isn't flawless. It can give wrong answers, especially when encountering something unusual or outside of its training. You may have seen funny examples online, like AI calling a broomstick a dog, or a chatbot giving a wildly inaccurate answer to a current event. It doesn't understand meaning. AI doesn't understand like humans do. It sees and reacts to patterns, not meaning or context. So, while it might generate a convincing sentence or image, it doesn't truly know what it's doing. Example: an AI image model once mistook a banana taped to a wall as a human face. Why? Because it had learned some pattern that vaguely matched what it was trained on, but it had no real world understanding. That's why we must verify AI outputs, especially in important tasks like healthcare, finance, or legal applications. AI is a tool, not a human brain. Let's wrap up by reviewing the key points from this session. AI versus traditional programming. AI doesn't follow written rules, it learns from data. Machine learning, a powerful method that helps machines find patterns and improve over time. Training versus prediction. AI first learns from examples, then applies what it has learned to new situations. Limitations. AI isn't perfect. It depends on data, can make mistakes, and doesn't actually understand. AI is transforming how we work, learn, and live. But it's important to see it clearly, not as magic or hype, but as a powerful, evolving tool that we need to use wisely and responsibly. Thanks for joining me. Stay curious, keep learning, and I'll see you in the next chapter.